Welcome to Ekeeda. In this video lecture, we are going to discuss one numerical based on Y-bus matrix formation by using direct inspection as well as step-by-step method. Here question is given. Figure shows the one-line diagram of a power system of a simple 4-bus system. Okay, here it is a 4-bus system is given to us. Table gives the line impedances identified by the buses on which these terminates. Okay, so between two buses there is a transmission line. Okay, and the line impedance of that transmission line is given in the table. The shunt admittances at the buses is assumed to be negligible. The shunt admittance, as we know, the transmission line, we model them as a equivalent pi model. So of course at both the ends we'll get some shunt admittance, but here it is said to neglect, because these are the negligible value. That's why it is assumed to be negligible and it is not given in the data as well. So here we are asked to find the two things. First, find the Y bus assuming that the line between 2 and 3 is not connected. Between bus 2 and 3, the line which is shown in the yellow color, first we have to assume that this line is not present. Okay, without considering this line between bus 2 and 3, we'll calculate the Y bus matrix. Then what modification need to be carried out in Y bus, the line between bus 2 and 3 is considered. Okay, see, firstly what we will do, without considering the line between bus 2 and 3, we'll calculate the Y bus matrix by using a direct observation method. Okay, and when we add an element in the Y bus matrix, how it will change? This will include the idea of step-by-step method. Okay, so the first thing, the table, it is given for impedances. Okay, it is given for impedance, that is nothing but R plus jx, it is given to us. But we are here finding admittance, so I need admittance which is in the form of conductance plus susceptance. Is it? It is in the form of conductance plus susceptance. How to find out this? We know that both admittance and impedance, they are reciprocal of each other. They are nothing but they are reciprocal of each other. So you can find y very easily just by using your calculators. Okay, you can find out this table very easily with the help of your calculators. Okay, you go in the complex mode, you write this value first. Okay, then you make 1 upon this value. Okay, this that will your calculator will give you this value. Okay, just cross verify these values. The impedance is given between bus 1 and 2 as 0.06 to 0.18. 0.06 plus j 0.18 it is given. If you calculate the admittance equivalent to that, you will get 1.67 minus j5. Okay, this way you calculate the admittances first. Okay, now we will directly try to write the Y bus matrix just by using the direct inspection method. Okay, of course it is a 4-bus matrix. The order of the Y bus will be 4 by 4. So let us try to write the Y bus matrix. I'm using direct inspection method first. Direct inspection method. I'm using the idea of direct inspection method. Okay. So the first term, it will be Y11. The second term, it will be Y12. It will be Y13. It will be Y14. Then it will be Y21, Y22, Y23, y24, then it is y31, y32, y33, y34, then y41, y42, y43, and then it will be y44. So these are the elements of the Y bus matrix. Okay, of course it is a 4 by 4 matrix. So now let us try to find out each element. Okay, so we'll directly write them in the matrix form. Let us directly try to write them in the matrix form. Y11, it will be summation of the admittances, or it will be the summation of the elements who are connected, which are connected to the bus 1. So I can see here the admittance of the line which is connected between bus 1 and 2, it is connected to bus 1, and the admittance of the element between 1 and 3 is connected to the bus 1. So I need to add these two uh, admittances. Okay, so I'm adding here. So the first term is what I need to consider here is admittance between bus 1 and 2. It is 1.67 minus J5. Okay, here we take the summation. So I will add the admittance of the line between 1 and 3 here. So for the line between 1 and 3, it is given 1.91 minus J 3.5. Okay, if you solve this, you'll get the answer as, just cross verify this, 3.58 minus J 8.5. This will be the Y11 term. Okay, Y12. Y12. It is simply negative of the admittance connected between bus 1 and 2. The negative of the admittance connected between bus 1 and 2, it is 1.67 minus J5. So we'll take the negative of that. 1.67 minus J5. Y13, it will be again negative of the admittance connected between bus 1 and 3. 13, it is 1.91 minus 3.5 na, so take the negative of that. So you will get here negative, of course, 1.91 minus J, it is 3.5. Okay. 1 4, is there any connection between bus 1 and 4? No connection, so obviously it will become 0. As I said, Y bus is a symmetrical matrix, so these elements will be same here. Okay, Y12, see here, this Y12 is same to Y21, Y31 is similar as Y13, and Y14 is as same as Y41. So I can write here these terms as, I can write them as minus 1.67 minus J5, this term as minus 1.91 minus J 3.5, and of course this last element here, it will be 0. Okay, then comes Y22. We need to consider the admittances connected to the bus 2. So here I'm getting two admittance. One is of the line which is between 1 and 2, and second is between the line between 2 and 4. So first I'll consider between 1 and 2. It will be 1.67 minus J5. Okay, this is the first term. Add it, sum it with the admittance connected between 2 and 4. Admittance connected between 2 and 4 is 0.24 minus 2.19j. Okay, so you'll get here, just cross check it, 1.91 minus j 7.19. Okay, just check it. Okay, then we'll go for y23. Y23 initially, in the case 1, it is said that consider it is not connected. So if as it is not connected, so this term will become 0. This term will become 0. No doubt you should mark here case 1, because we are solving for first part. Okay, so it will become 0. Y24, Y24, it is connected. You consider negative of the admittance between bus 2 and 4. What is the actual admittance between bus 2 and 4? It is 0.24 minus 2.19. So take the negative of that. If I take negative of that, I'll get minus 0.24 minus j 2.19. Okay, as it is symmetrical matrix, so this term, it will become 0, it will become minus 0.24 minus j 2.19. Okay, now y33, it is on this bus, this line is connected, which is between 1 and 3, and which is between 3 and 4. So I need to add, consider 1 and 3 first. I'll consider, I need to add these admittances of these two lines. So first I'll add for 1 and 3. It is given 1.91 minus 3.5j, okay, plus between bus 3 and 4. Between bus 3 and 4, it is 1.34 minus 2.67j. Okay, you'll get here, if you solve this, just check it whether you are getting the same thing or not. You should get here 3.25 minus j 6.17. Okay, next 3, 4. Negative of the admittance connected between bus 3 and 4. What is the admittance between bus 3 and 4? It is 1.34 minus j 2.67. Now, so it will be simply negative of 1.34 minus j 2.67. As it is a symmetrical matrix, so you'll get the same term here, minus 1.34 minus j 2.67. Okay, now y44, it will be the addition of the admittances connected between bus 3 and 4 and between 2 and 4. So first consider between 2 and 4, it is 0.24 minus 0.2 minus 2.19j plus between 3 and 4, it is 1.34 minus 2.67j. Okay, if you solve this, you will get, you just check, 1.58 minus j 4.86. Okay, so this will be your y bus matrix. Okay, of course it is considering that the line between 2 and 3 is not connected. Okay, it is with that consideration. Now we'll go for the case 2, which says, now consider the line between 2 and 3 is connected. When the line between 2 and 3 is connected, what will be the changes? Now simply what we are doing here, I will write here addition of an element of admittance. Now, what is the admittance of the line between which is between 2 and 3? It is 2 minus j4 addition of an element of admittance which is 2 minus j4 will affect, okay, I directly we should not consider whom it is going to affect. First we should mention it, it is between which two nodes. Addition of an element of an admittance 2 minus j4 between bus 2 and 3 will affect, of course it will affect y22, y33, y23 and y32. It will affect these four entries. So let us see how it will affect, or what will be the changes we will observe here. So first I'll write for y22 new value. It will be y22 old value plus this term, which is 2 minus j4. Okay, so what value we'll get here? You just check. What is the y22 old value? It is 1.91. It is 1.91 minus 7.19j. Okay, we need to add that with 2 minus j4. Okay, if you do that, you'll get this term as 3.91 minus j 11.19. This is the term which is going to modify. Okay, again this term will get modified and these two term will get modified. Okay, now we'll see the modification on this y23 and y32. y23 new, or what we can say y32 new, both are nothing but the same. It will be y23 old plus 2 minus j4. Okay, it is minus, not plus, because it is a transfer admittance. So it will become minus. When it is a self admittance, it will become plus. When it is a transfer admittance, it will become minus. Okay, so here anyway y23 old is 0, so you will get a value here minus of uh, in the bracket 2 minus j4. Okay, then the next term y33 new value is equal to y33 old value. Okay, it is a self admittance or driving point admittance. We can add it 2 minus j4. Okay, just do this addition. It is saying 3.25 minus j 6.17. Okay, it should be added with 2 minus j4. Okay, you solve this and you just check, you should get the value as 5.25 minus j 10.17. Okay, so this is how these four values are going to modify. Okay, so now after this modification, let us write the final y bus matrix. So the y bus matrix will be, so first term 3.58 minus j 8.5, 3.58 minus j 8.5. Okay, next term minus 1.67 minus j5 minus of 1.67 minus j5 it is. Okay, next term it is minus 1.91 minus 3.5, 1.91 minus j 3.5. Okay, and it is 0, of course, it is 0. Okay, now here it is second term, it is minus 1.67 minus j5. Okay, y22. Now we'll have to write the new value. It will be 3.91. It will be 3.91 minus j 11.19. Okay, y32. It will be now, earlier it is 0. Now it will become minus 2 minus j4. Is it? Because it is 0 here and we are modifying it as minus outside the bracket, in the bracket 2 minus j4. This value is not going to change. It is minus 0.24 and 2.19 minus 0.24 minus j 2.19. Okay, so here these value will remain same as it is symmetrical. So here minus 1.91 minus j 3.5 will come. Okay, here this entry will come minus 2.j4 will come here. Okay, here y33 will come. Y33 also it get modified. Its value is here. It is 5.25 minus j 10.17. Okay, and this value, it is not been modified. What is the value here? It is 1.34, 2.67. It is 1.34 minus j 2.67. Okay, and the last column here, it will be 0. It will be this, of course, this value will come here minus 0.24 minus j 2.19. Okay, and then this term will come minus 1.34, this term minus j 2.67, and the y44, it is 1.58 and 4.86. It is 1.58 minus 4.86 minus 4.86. So this is your y bus matrix. We have utilized, or we have used here both the methods, direct instruction method as well as step by step method. Okay, thank you very much.